So let's just roll down the first column on the left first. And if I'm multiplying with the same base to an exponent times same base with an exponent, what can I do with my exponent? Add them. The reason I can do it is I have that many factors. So I'm going to add here and get 7 to the 11th. Would add here, get 3 to the 5th, 2 to the negative 7th, and 5/6 to the 9th. Are we all good there? Now here's the deal. Out of that column, which one do you think is the one kids try to skip the most? Yeah, but did that fraction make anything harder? No. I think it makes it the same because, like, let's say we had poo emoji to the 4th times poo emoji to the 5th. We get poo emoji to the 9th. Okay? So, the fraction doesn't make anything there crazy. So don't be afraid of fractions. All right? When I have a quotient, the quotient property tells me I can do what with my numerator and or with my exponents? The quotient property tells me what can I do here? I can subtract them because things are canceling. So I get 3 to the negative 23rd. I get 2 to the negative 9. 6 to the positive 13. And 10 to the 8. Now, on that column, which ones are the toughest, would you say? Maybe the last two? The last two? So, there's, especially for that third to last one, this one right here, third to last, second to last. Here's how I see this. A lot of people do this. They do 6 to the 5th minus negative 8. That's fine. Here's what I see, though. I see the reciprocal of this, putting it in the numerator. So I actually just see 6 to the 5th plus 8. I see them both as positive. These say the same thing. A minus negative is plus. Just in my head, I envision my negative flipping, reciprocal, and becoming a positive in the numerator to combine. So that's just how I see it. Same here. With the 10s, I see this first in my head as 10 to the 20th over 10 to the 12th, which is 10 to the 8th. I do the reciprocal and get my exponents to be positive before I start doing math to them. That's just before I start doing computation. It's just a different way of viewing it. Okay, and then I have a power to a power. What can I do with those exponents? Multiply. So 7 to the 6, 4 to the negative 9, 2 to the 32nd, and 6 to the negative 15. None of those really stick out as being crazy to me. But power to a power we can multiply. Because we have that base inside that many times. And repeated addition is multiplication. In terms of skipping stuff, don't be scared of fractions, okay?
Fractions are our friends.
Fractions are our friends. And then you can consider getting negative exponents positive first. Just something to consider. You don't have to. Just something to consider. For all these, there's two ways you could write it. I'm going to end up only writing it one way. But for 2 to the negative 7th, we could write it as 1 over 2 to the 7th or 1/2 to the 7th. You cannot write this, though, because only the 1 would be raised to the 7th there. So I've got 1 over 3 to the 23rd, 1 over 11 to the 8th.
I think I made a good mistake.
Yeah, you could have made a great
I did
mistake.
negative 7 to the second. What did I do?
Well, does a negative exponent mean negative answer?
No.
Nope. It just means reciprocal. Remember? Yeah, that's a good mistake. But again, negative exponent has nothing to do with positive or negative. Only reciprocal. So, anything divided by itself is 1. So I got a 1 there. I got a 1 there. And anything to 0 power is 1. So we just took care of the 1s. 1, 1, 1. Because this would be 2 to the 0, right? Which is 1. Let's get another color going here. So, 2 ways you can think about 2/3 cubed. You can think about it as 2/3 times 2/3 times 2/3. Or you can think about it as 2 cubed over 3 cubed. Same thing. Which is 8 27ths. That goes that 2/3 cubed. Well, 3 cubed is 3 times 3 times 3. 3 cubed isn't 3 times 3. It's 3 times 3 times 3. So 3, 9, 27. Good mistake. So then we got 5/4 squared. That's 5/4 times 5/4 for 25/16. I got you. I just did blue and gold for today. I don't think so. Not academically. Okay. And the last one, 7/2 squared would be 49/4. So you can think about that as 7 squared over 2 squared, or 7 squared, or 7/2 times 7/2. So let's take a look. What I'd like to look at is what does the left side and right side mean as factors? So left side we'd have a 2 times 2 times 2 times 5 times 5. And on the right side we have 10 times 10 times 10 times 10 times 10. Okay. So there's our left side and there's our right side. Do I have 5 factors of 10 on the left side?
Yeah.
On the left side I have 5 factors of 10?
No.
Now how many factors of 10 could I make on the left side?
We can make
Make one here and one here.
2. 2 and
So the left side could be equal to 10 squared times 2, which is 200. The right side is 100,000. It's a big old false. So, my true friends, what you are doing where you are going based on memorization versus understanding. If you look right here and say, hey, these are my factors, there's no way you can say true. There are not 5 factors of 10 on the left side. Right? So don't just be like, oh, look at that. I can add exponents. What is true about my bases?
they're different.
My bases are different, so I don't have some factor over and over. Right? I have 3 factors of 2 and 2 factors of 5. But if I wanted to make my computation life easier, I can rewrite this as my 2 factors of 10 and a 2 to get to 100. This is mental math I would do to do this in my head. Okay? But these are not equal. Not even close.
Honestly, 8 times 25.
Again, though, do you see why I want you to take that step back and go by concept?
And 8 times 25.
I knew it was coming. Good mistake. Good mistake if you made a mistake. But how many people could see it? How many people could see it right here, though? How many people could see it right in there? Yeah, so take that step. Imagine what it is expanding. Because I didn't do anything fancy in math there. I just expanded it, right? All right. Number 1, let's take a vote. True or false? Who's got a true? Who's got a false?
We believe it's true.
Okay, same base. We can add our exponents. Number 1 is true. If you expand it out, you got 2 factors and 4 factors for a total of 6 factors. Number 2, who's got a true? Okay, who's got false? All right, let's look at it expanded. We'd have 3 times 3 times 5 times 5 times 5 equals 15 times 15 times 15 times 15 times 15. So, if this isn't true, here's how I can make it true. I could say 3 to the 5th times 5 to the 5th equals 15 to the 5th. And here's why this is true. If I have 5 factors of 3 to go with 5 factors of 5, that's 5 factors of 15. Let me show you. I'm running out of room. It's all right. Would you guys agree that this is 3 squared times 5 cubed still? So 15 times 15 times 15 times 15 times 15. If it's an emergency, I'll show you sign. So you see all those factors of 15? Every one of those pairs is a 15, right? So that's how I could make that one true. All right. Let's take a look at number 3. Number 3, raise your hand for true. Raise your hand for false. How could I make this one true? Who's got it for me? Josiah? Yeah. Otherwise, you have to do this first and this first, and then add them together, which would not be 5 to the 9th. Okay, number 4, raise your hand for true. Raise your hand for false. All right, let's take a look. It is false. What I have here is 3 factors of 10 in my numerator, 4 factors of 2 in my denominator, which is not 7 factors of 5. Now, if I wanted to go factors of 5 here, I have 3 factors of 5. So I could do like, if I want to simplify my left side and make it true, I could cross that off and write 5 cubed times 2. That's one thing you could do. But what I think I probably would do is if I had 7 factors of 1/2 and 7 factors of 10, that'd be 7 factors of 5. Because each factor of 10 and 1/2 together makes 1 factor of 5. That would work. Again, each factor of 10 and 2 would equal 5. What about the last one? Raise your hand for true on the last one. Raise your hand for false on the last one. Okay. It's true. Here's why. 3 times 3 times 5 times 5. Here's a factor of 15, and here's a factor of 15 for 2 factors of 15, which is 15 squared.
I think you're going too much memory.
Do you see how it just pops? This right here is the easiest one to understand, I think. So if you're like, what is he doing? Look at this one again. If I get my 3 squared and my 5 squared, do you guys see this factor of 15 right here? And this second factor of 15? That's 15 squared. I can only do that because there's the same number of 3s and 5s. I can pair up each 3 and 5. Okay? That's why, notice, on number 2, if I had the same numbers of 3s and 5s, I could do 15 to the 5th then. It's why the same reason on number 4, I had the same number of halves and 10s. That's why I could do 5 to the 7th. Because I can combine my bases if I have equal factors, because then that multiplication makes sense.